This is Senior Algebra Section 5.1, the product and power rules for exponents. So we're taking a look, we're going to be simplifying some exponents here, and we're going to look at some rules that make it a little bit easier to simplify this. So in example 1, we're going to expand and evaluate those. We're going to write out, when it says 2 to the 4th, what does that actually mean? We're going to expand it out, name the base and the exponent here. So the base is 2, the 4 is our exponent, and it means we take the base, multiply it by itself however many times the exponent. So 2 times 2 times 2 times 2, 2 to the 4th, that is 16. In B, my base is negative 4. Now, I actually made a mistake on this. I actually put it to the 4th power here. It actually should be to the 3rd. So let's ignore that last negative 4. So it should be negative 4 times negative 4 times negative 4. Negative times a negative times a negative is going to be negative. And 4 and 4 is 16. 16 and 4 should be 64. So the answer you should get is negative 64. I accidentally did it to the 4th power. In C, now the negative out there really means a negative 1. Okay, notice the difference between B and C here when it's in parentheses and when it's not. So really, it means negative 1 times 4 to the 3rd. The only thing that is being raised to the 3rd power is the 4, not the negative, unlike in B. So it's negative 1 times 4 times 4 times 4. 4 and 4 is 16, and I get negative 64. A little different way to get it, okay, but the process is the same here. So indeed, I'm going to multiply those together. 2 squared means 2 times 2, 2 to the 5th. 2 times 2 times 2 times... Now, if I wanted to put those together, what is 2 times 2 times 2? That is 2 to the 7th power. We can evaluate that if we wanted to. 2 and 2 is 4. 4 and 4 is 16. 16 and 4 is 64. And 64 and 2 is 128. X to the 3rd means x times x times x, and of course x to the 1st is just 1x. How many do I have then? I have 4 x's, so it's going to be x to the 4th power. In F, it's x cubed to the 4th power, so my base, x cubed to the 4th power. That means x cubed times x cubed times x cubed times x cubed. Oh, what does x cubed mean? That's x times x times x. So I'm going to write all this out. Now, looking at this, of course, okay, this becomes a little tedious. That's why we have shortcuts here, or some of the rules that we're going to get to here. But for right now, okay, where the rules come from? Well, they come from this, from expanding it out and writing it correctly. So in G, I'm going to do the same thing. X to the 3rd power. It's x to the 3rd, x to the 3rd, x to the 3rd. X to the 4th to the 2nd power, x to the 4th, x to the 4th. And now I'm going to expand it all out.
Early, so I don't know where to go.
I'll close the door.
What?
We'll close the door. So I'm expanding it all out here. Again, yes, it is tedious. However, it makes us appreciate the rules that we get to, that we can shorten the process here a little bit. But if you ever forget the rules, you can always expand things out. So I should get x to the 17th power. In H, 2x third to the 4th power. That means 2x to the 3rd times 2x to the 3rd times 2x to the 3rd. Now again, this is all just multiplying here. So I could group these together. 2 times 2 times 2 times 2. And then x to the third, x to the third, x to the third, x to the third. 2 and 2 is 4, 4 and 4 is 16 there. And if we remember from above, x to the third times x to the third times x to the third times x to the third. Again, I could expand that out, but remembering from above, yeah, right up there in the upper right-hand corner. Yeah, it was x to the 12th. So I'm going to take that shortcut and just say it is x to the 12th. In I, I'm going to do the same thing, 3/4 to the third power. That means 3/4 times 3/4 times 3/4. That gives us 27 over 64. So, how can we shorten this stuff up? Okay, because if I look at g here, having to write that out every time to get x to the 17th, that's a little tedious. And we want to be efficient in this. If I write out x to the third to the fourth, do I write out x to the third? What can I do to shorten some of these things up? That's what I'm trying to do here. So we look at it, and that brings us to our rules. How I can shorten things up. A is our base. Then I'm going to add the exponents together. So when I am multiplying, product means multiply. I add the bases together. The key is the bases have to be the same. So when I have 2 to the second times 2 to the fifth, I can just add 2 plus 5 together, get 2 to the 7th. I can do the same thing for the power rule. I have different types of power rules here. Power to a power, exponent to an exponent, x to the third to the fourth. Again, we looked at that, but the shortcut is to multiply them together. Could I expand it and write x to the third, x to the third, x to the third, x to the third? Sure. But again, we're looking for a more efficient way to do it. When I am multiplying inside, it's going to go to every term here. So I have the 2 to the first, that's 2 to the fourth, x to the 12th. And 3/4 to the third means 3 times 3, 3, 4, 4, 4. Or 3 to the third over 4 to the third. So in these, we're going to use these rules to do our simplifying here. The bases are the same, so I can just add them together. 4 and 3 gives us our 7. In B, that's to the first, so it's -4, 3 plus 1, that's going to be 4. And -4 to the fourth power, we could multiply that out if we needed to. In C, again, that -1 times 4 to the third, -1 times 4 squared. Well, 4/3, 4 second, that's going to be 4 to the fifth. And then -1 times -1 just gives us 1 here. So I can just write it 4 to the fifth. In D, so things I have to remember here, the exponent only goes to the x there. It does not go to the 2. So this is 2 times x squared times 2 times x to the fifth. I can group those together. 2 times 2 is 4. And then x to the, when I add 2 and 5, I get 7. In E, if I look at my base is 2x. It's that whole thing. So first I'm going to use the power rule. It's 2 to the first. Okay, and that. So my bases are the same here. So 3 and 9. I'm getting old, I need glasses. That's going to give me 2 to the 12th and x to the 12th there. In F, now my bases are not the same, so I can't really just add 4 and 2 together. I'm going to have to expand it out a little bit. So I'm going to use the power rule, 2 to the 4th, x to the 12th, 3 squared, x to the 2nd, y to the 6th. 2 to the 4th, I can multiply that out. 3 squared, I can multiply that out. Notice I can't just add them together because my bases are not the same. But we know 2 to the 4th That's 16. 3 squared, that's 9. 9 times 16, that gives us 144. I'm going to put my x's together. I have 12 and 2, so I get x to the 14th, and then y to the 6th. And now finally the last ones here. There's a negative there. Again, that means -1. So I'm going to do it to every part inside the parentheses. So it's -1 to the second power. X to the 6th, y to the 6th, and z to the 8th. Morning, guys. I have a sheet. -1 squared, we know is just 1, so I should get as my final answer x6, y6, z to the 8th. In h, everything inside the parentheses is raised to the 4th power, so it's -2 to the 4th, x to the 12th, 2 squared, x to the 8th, y to the 2nd.
Elizabeth, Montilla, please come to the office at this time.
Twice this weekend.
I'm going to talk for a minute or two.
Straight pipe.
So, I have 3 cubed, x to the 6th, 4 to the 3rd, y to the 3rd here. I'm going to simplify that, get 27x to the 6th over 64y cubed. As you can hear in the background, class is going to start here in a few minutes, so good luck, have a nice break.